Yeah. Or that other one. I don't know how that other one is.
Which one's that?
You said you saw a couple of them when you're at Micro.
Oh,
I
yeah,
think.
yeah, yeah, yeah. They should be able. Can you jump into one of the streams, either on Twitch or YouTube, and I'll check the other.
On Twitch.
Shows that it's
A couple
live.
of them when you're at
Oh, okay.
Micro.
Oh,
I
yeah,
think.
yeah, yeah, yeah. Yeah, you're just a little bit quieter than I am. Can you jump into one of the streams, either on Twitch or YouTube,
But way
and I'll check
cooler.
the other? Yes, way cooler.
Twitch.
Steamier, some may say.
Steam.
You know.
Hmm.
They can hear us while we're up above in. I just need. I know there's a way for me to just see the comments, like monitor comments on the tubes.
DOS tubes.
Das tubes. So comments, my channel. All right, one watching, and I think it's me. The comments, like monitor comments.
I'm the
Okay.
one watching. It's me.
Close this out, and then do a blast. A blast.
Blast.
Oh wait, the YouTube should come in on here. Twitch is the one I won't be able to see.
I am out on your YouTube.
You're not?
I don't think so.
Oh.
Or am I? There's a
What?
little wrench next to my name.
You should be.
Okay.
Yeah. So I should be able to see the YouTube one. I sent you a link for doing the, like, it's just a spreadsheet for doing whatever people say, have suggestions. So you know what I'm
Who's
saying?
this link at?
It should have gotten in your email.
My my email, Hotmail or
Gmail.
Gmail.
Hey.
Bastards.
What?
Boy.
You know, I had to. I just had stuff. Man, I hate Facebook so much.
What?
I hate
What do
Facebook.
you say about the Zuck attack? Okay.
The Zuck.
Mm-hmm.
I post something and it's like, do you want to create an event? No, I don't want to create an event, you silly goose. You silly goose. Why is it? Now it always takes me to our other channel. Okay. All right. Now we should go on. I have it recording now too, so I can splice it up. All right. I don't think we got anybody yet, do we? Well, maybe. Looks like we do. Are you on both?
Oh, I'm on both.
Oh, okay. It may just be us. Okay. So I just got the files pulled up from the old Apollo.
Oh, we're getting some people.
Hmm? On
Or
which thing?
YouTube, Twitch.
Oh,
YouTube's still quiet.
I'm in the chat. Homie, it's me. Hi.
Mm-hmm. What about chat?
I try to chat, and it's like, no, you gotta sign in. Like, it's me. All right. Oh, I found a way to do the whatchamacallit. All right. Oh, hi, Aaron. F geared. How's it going? So we're going to be working on a new project we got here. I'm going to be switching between some files here. Okay, sounds good. Thanks, man. Uh, so what some of you may know is, sadly, I'm using a big. I use widescreens for designing, so you're not going to be able to see my like directly to the left over here is my like all my projects files, and I had to choose between you guys being able to see more of the design, more of the project files. If you guys want to see more of that, we can do that and change it up a little bit. I might just get a different display for this, but what I'm going to do is I'm going to open up one of these files from what was the original. Like, so we announced the Apollo just over a year ago, and we saw a lot of people. Um, saw a lot of people come up with other printers. You've got the Wuxins and I mean, this one doesn't show enough. Different one. And Prusa came out with the MK4 and stuff like that. And there's a little bit more competition in the area, and it made it kind of hard to justify the Apollo. Um, Everything was going great with it. We had no problems with it. The problem was the market is kind of full, so we decided we were going to change some things up. Maybe this will show us a little. Nope, this was not even going to show us anything either. I got to find the right file to show you guys. But anyway, so we had the Apollo. You're going to see a couple of the files. So if you can see here, this is like a Prusa style bed mount. But yeah, it was a bed slinger. That's what we tested our breakboards on, which you can, right now they're sold out on the site, but we plan on getting some more in. And another thing we did was we were running the Duet 3 Mini. So we have a handful of parts left over from the Apollos. One of them being this come on. This crossbar. And this is how it was oriented on the Apollo. You may hear my dogs yelping in the background momentarily, but can you hear them, Brandon?
A little bit once in a while, but
Yeah.
they've been pretty good.
Yeah. We can't have all the dogs up today because one of our dogs had a tooth pulled yesterday. So, anyway, so we have some files or some parts left from the Apollo, and there was a handful of things we liked from the Apollo and we wanted to keep around. One of them being the bed. So do you see this? It's called a Leica. I don't know if you can even see that on here, but this was titled the Leica bed just because that was our initial name for the Apollo. But anyway, so this is actually an MK3, so so your MK52 style bed, 24 volt. It's we had them made by LDO. They were really nice. The big advantage is the flex plate, right? So the flex plate is your like one of our like shining factors of this specific this specific bed was this flex sheet that they're made everywhere. Everybody has an MK3 flex plate. If you want to go with what's their names? The guys down in Florida. PEX, the guys who make PEX.
Make what?
They make the PEX sheets. I'm trying to think.
Filamentum or Phila.
No.
Not Florida.
Yeah, they were down in Florida. What was their names, Brandon? They're still around. They make the slap mat. They make the flex plates
Wham Bam?
Wham Bam. So Wham Bam's got their own. Oh, I don't know. See what you're thinking about. Filament. They make their own. Like
Yeah, filament.
everybody.
What's
Yeah.
Gizmodorks?
I think they're just a random um place. I don't think they're anything um too crazy.
Okay.
Like I think they were around for a hot minute a while
Oh
ago.
yeah, they sell filament
They
and
sell filament. They sell a lot of different things. Gizmodorks. Oh yeah. You used to be able to get Garolite sheets from them back before anybody else had Garolite sheets. Anyways, so everybody had these flex plates, and that's the big thing is if you want a specific blend, a specific way, you can do it. So we want to keep this bed because we also have a handful of them. We already have these rods or these cross braces already milled. So we want to use them. And they're almost a perfect size. So the Apollo was a Core XZ. What we want to make is a Core XY. So we do have a list of things that we want to, like goals that we've set for ourselves. And I think oh, here they are. So right now, our goals for this is we want to be we want to be sub $1,000. It's going to be a kit printer, is what we're thinking. Fast as possible, easy to assemble. One thing we want to do is we want to make it to where we're going to build a halo. So we did a bunch of test fits for this, and we can show you some of those. So we'll show you this. This fit up was kind of our test, right? So we'll put rails in the bottom for our Y, a rail on the top of this carriage for our X, and we're still able to use all the holes and everything like that. That's great. But we want to make this setup in-house. And we want it to be assembled. We want rails to be on it. We want belts to be on it. We want the carriage, at least the carriage mount to be on it. And then at that point in time, we want people to be able to buy extrusion for your Z that would mount into these holes here in all four corners. You can change the height. The way we'll be able to do that easily is a belted Z. Still using our Z brake motors that we used before on the Apollo. And then so that if somebody says, hey, I want a 500 millimeter tall version of this thing, they can have a 500 millimeter tall version. You're not going to get any Z wobble because they're going to be belted. You're not going to have the problems of, hey, I want to have a 361 millimeter tall Z. You'll be able to do it. You just have to get that right extrusion and then extend your belt. So there's going to be a couple challenges to that we're going to have to get around. Mainly is how are we tensioning the Z belts and how are we mounting the Z extruder or the Z motors. So what we're going to do is we're going to kind of start from this base. This was nice. This was a good fit up. This is just showing us that everything we were thinking could fit in this space, but we actually want to make this a little bit bigger. A couple things, Brandon, if you want to add them to that for goals for that sheet, is we want to have the ability to use. So let's close this one. We'll open up a new file. We want to be able to use the what's that touch off system? The in stop.
Similar to the one that's off the build plate. Or are you talking the magnetic?
The magnetic one.
Lucid probe.
The Euclid probe, right?
Euclid probe.
Yeah. So we're gonna insert not that. We're gonna insert a DXF because we have the original one that we worked from, and we're going to work from that. Just call it the horseshoe. It gives us some kind of a design here. I don't know if I rotate this. No. Okay. So one thing was we were on the original one, we were countersinking these bolts holes for the motors Well, if you do that, it limits the ways you can manufacture it. And one thing we want to do is we want to have this. We want to have as many options as possible. We're making this in the U.S. We're a U.S. based company. We have to pay U.S. wages, um, and but we want to be able to keep the price of the unit itself down. So what we would do is we would go 6.35 mil thickness. Of course, we're going to work in millimeters. That's kind of what we always work in here. So we're going to go 6.35 millimeter thickness. It's going to give us a 1/4 inch plate. But what not having countersunk holes allows us to utilize different manufacturing methods. If we were to do countersunks, are those counter boards? Boards, right? Angled.
Yep.
So they would be counterboard. Sorry. So if we counterboard these, so the heads of the bolts could set recessed in the extrusion or in the aluminum, we would be limited to things like just like standard, milling. To like using a vertical machine or a router style mill to machine this. If we stay away from any of the counter boring, we can utilize fiber laser. Or, I mean, you could do water jet. Water jet is super inaccurate when it comes down to it. When it comes down to holes like this, these are M3 holes. Another problem is we want these to be accurate because here we're going to, like this hole here, it's an 3.5 mil. That's what it's set up for here. So that's a whole size set for an M4 tap. So right now, the majority of this that's not going to change is this back right here. This area is pretty. The motor placements and stuff like that should work very well. We do have to add something here for being able to mount the third linear rail for the Z. So we're gonna have a 3-point rail system so that we can actively tram our beds. So we want to be able to do that, but we also it'll be pretty accurate. Really, you're not going to have to change too much, mainly because we are working from a bed that's only this size. So a Prusa says it's 250 by 220 or 230. Or no, it's 220. I believe in Y. So we're going to use this same bed, same flex plate. So we're going to kind of be limited to similar setups. You can, if you look out of Prusa, it tends to stop the line. Let's look here. Pull this back up, sorry. It tends to stop the line like right here. And if you look at the bed at the bottom, the traces don't go all the way to these edges here. So you can try to print all the way up here, but you're going to be limited on your heat dissipation from that side of the bed, stuff like that. So we kind of want to keep it in that area. So what this is going to do is it's going to place this printer in between something like a Voron 0 and all your Prusa style printers for build volumes. It'll be in between those. Really, it'll be right around that Prusa style, but it's going to be less than your 300 by 300. But you're changing out that extra space if we went to a 300 by 300 by ease of flex plate accessibility, right? But also we would have to make a custom bed. And the way we make custom beds is we don't make PCB bed like this ourselves. We would have to go with something like a Mike 6 plate with a silicone heater on the back. Problem is with that is costs, really. And since we're doing a belted Z, the weight of the bed is going to be one of our biggest issues, right? We don't want it to be too crazy heavy. But one thing we want to do with these streams, we're going to design the plan is to design this whole printer in streams. What we would like is if somebody has an idea, somebody has a suggestion, somebody has a desire to have a specific feature, a specific thing in a printer, let us know. We would like to incorporate those things. big thing is like we're trying to make this more of the Maker-esque printer. We have the Daedalus printers, we have the new Talos printers, and neither one of them are really priced for a person who just wants a desktop printer on their next to their computer, or makers. They're not really priced at. That's what the goal for this is. So if you guys have any ideas, feel free to post them in the chat. Let us know, and we'll see what we can do to work those ideas in, and we'll give you credit for those ideas. We have no problem with that. So we do have this. What we're gonna do first off is we're gonna just probably cut the fronts of this part off, because we're probably gonna want to extend this, because I have some new ideas that I'd like to try. So we're going off of no.
Is the Talos a desktop printer?
I mean, it depends on the size of your desktop. I mean, Brandon, did I not talk about having like a platform to go under it to put the filament in? So it's kind of a desk. It's kind of a desk. So the idea would be I'd like to extend this out, mainly because if we look, let me pull up our old one so that I'll be able to reference back to it quite often. But I'd also like to share this file online so people can kind of tweak things to it, stuff like that. If people want to build this themselves, feel free. Like, by all means, there are a lot of new ways to make printers now, which is awesome. A lot more things that are accessible to us. Another thing we need to come up with is a name for this sucker. Right now, it is called New Project. Before we were calling it Project Mercury, just because of Project Apollo, but Project Mercury, there's also like we're not, those were internal names. We can't really go Project Mercury and for release. Well, no. Let's call this. So right now it's just called New Project, as you can see. But we can't really call it Project Mercury because there's a couple other printers out there with the Mercury title, and we don't want the confusion. So one thing we do have a lot of is these 300 millimeter long MGN 12 with the 12 MGN 12H carriages, which are the longer carriages. So we are going to be using those in this printer. So our base height is going to be the 300-esque. Oh, come on. Why you do me like that? Yeah, exactly, Brandon. Why do you have to be so rude? And of course it's not. I hate when it does that. It doesn't go to the actual center of the circle.
Yeah,
so
frustrating.
Yeah, and it's because of these rails they're designed with this line in them, which nobody cares about. Let's be real. For most people, it doesn't matter. Okay, there we go. Just have to select the right thing. There we go. Look at that. Lined up perfect. First try. Okay, so this is kind of the but kind of where we're already starting. So we have Y rails, and then we'll mount up the cross brace. And these things aren't really going to change the rail size for the X and Y, only because it's what we already have on hand. This is going to be kind of the update for the Apollo. This is what's going to change from what from the other design. So we're going to go here, go down here. So if we look at the top down of this guy and the top down on this one, you'll see some changes. Let's go ahead, so we can look at it the same way. So you see how we've got the idlers in the front here, and here we're going idlers in the back. So when we were designing and doing fit ups for this guy, the carriage itself, we were having problems with where the belts came in and the options for extruders. If we were building a printer for us and we were going to say, hey, we're only gonna use a Chimera. We're only gonna use an LGX. We're only gonna use an Orbiter. That's fine. That's great. That's all snazzy dazzy, right? The problem is we don't want to tie down this printer. We want people to be like, hey, I want to put an orbiter on this. I want to put make a modification to put a the mini stealth burner on this thing, anything like that. We want you to be able to do that. So what we're gonna do is move the belt attachment points to the back of the carriage. So you can hang whatever you want off the front. And that's the idea there. So the one thing I don't like, and you're always going to hear me complain about this, is the height from here to the top of this idler. We can do it. What we're going to have to do is we're going to have to tie these two together. Shoulder bolts are expensive at the end of the day, so we don't want to go too crazy with like really long shoulder bolts and stuff like that. We're going to have to go with hardened steel shoulder bolts. Not that big of a deal, but we're going to have them both be the same height so that we can tie them together. So you actually are going to have pulling from the back and from the front. So we shouldn't really see the any issues with the fact that they are that tall. Really with the spans of these belts being so low, you're not going to have a crazy amount of tension on the belt. The longer your GT2 belts and stuff like that, the higher the tension it's got to be to get the resonance you want in that belt, to know that you've got it to the proper tension. So because this is going to be a much smaller machine, you shouldn't really have those issues. We do want to keep the same way of adjusting belt tension to the motors. We have a couple ideas for that. But we want to keep it off the front idles. If you look at the Talos, we use a cantilever system. We could do that on this. The problem is the price. The price in those metal parts and price of making those metal parts accurate and to where they don't wobble, it's expensive. So that's gonna hurt the fact that we want to keep it a sub $1,000 printer. So yeah, so that's why we're thinking of moving this to the back, and then we could bring in another rail. We'll get back to kind of where we started. And does anybody already have some suggestions on what they'd like to see in a maker-esque printer? I need to turn this before I set this in place, but I'm an idiot. So you guys are gonna see, this is gonna be pretty quick modeling, and then what happens is I normally go back and I put everything in their little categories and stuff like that and make it easy for manufacturing. But until then, see, I did it again. Idiot. Luckily, we don't do this very often. Come on, pick the right thing. Didn't do it again. There. I think I got it that time. Just got here. Hi. Trying. Wait. Trying to remember. Oh, never mind. I know who you are. I was like, I know this name. I know it. I know it. All right. How's it going? I'm glad I'm not the only one who's doing line 5 times to get it right. Man, that's the story of my life. 5th time's the charm. And I'll just cry during the first 4 times. Okay, so the motors we're using. We also have a standard motor right now. We have some fill-in ones because we use motors from LDO. So the rails are LDO. The motors we use are also from LDO. We don't have the specific design for what we use itself. But so these are going to be stand-ins. Because let's be honest, a NEMA 17 is a NEMA 17. The only thing that really changes is the length. These ones don't have a weird orientation on them, so, or weird. Come on. Nope. And I picked the wrong one. See that? Like a dingus. There it goes. Okay, apparently I picked the wrong one again. Because I'm another dingus. There it goes. All right. So our normal motors have the plug in the side, so these are kind of moot. Our motors are also 68 or 48 millimeters long. They're 0.9 NEMA 17s. They're 48 mil long. They're a little bit beefier. They are what we use on our X and Y for the open loop Talos. It's also what we're using for the X and U on the Talos. And currently the Talos, we're sitting at, with all metal parts on X and U, we are limiting it in firmware. But it was able to outrun it if we took off the limits at 1,074 millimeters per second. So you're gonna hear my dogs barking again just because my significant otter came home and they are gonna lie to her and tell her that they didn't eat this afternoon. Which I should probably text her and let her know that they are liars and they did eat. Let's get this plate in place. Right now, we're just gonna try to get everything kind of in spot so you guys can kind of see what we're working with. We gotta change out the front idler. Nice thing is we can kind of go back to our sketches. Now look at this horseshoe, because I know this, if we put an idler, front idler there, it's going to line up perfectly to where we can hit that back motor. So what we'll do is we'll turn off this sketch and let's double check and make sure that we don't have anything. Nope. Okay. So I want to make sure I didn't miss anybody. So, does anybody, like, what are your guys' favorite extruders? So, I was starting to design this with the LGX Lite and the, what's the other one, Brandon? I already said it like 5 times. Orbiter.
Okay.
The reason why we can't do a Hemera on this is if we pull in a Hemera. I know I got a bunch of these files on here. Let's go off just the Revo. Or this is the only really Hemera you can get now, is the Revo one, right?
Mm-hmm.
And it's the XS, and they've killed the standard Hemera. So if we look at it off to the side here, of course it's all wonky. This is the reason why we can't do the Hemera. We're gonna need like a 5 mil plate from the carriage up. So let's move up like 5 mil. The problem with the Hemera and a Revo right now is the nozzle's never gonna touch the bed. You're just gonna hit things. Bamboo Lab bed size is 256. Spring steel sheets available for that size now. Yes. The problem is those bed sizes are not readily available. I completely agree. There are a lot of spring steels. A lot of people jumped onto the bamboo wagon. Can't blame them. There's a lot of them out there right now. The problem is I would have to get a bed made. I don't even, does Bamboo sell their beds by themselves? You would think they would. They're starting to sell a lot of their things. Let's look. Parts, right? The X1 series. Another problem, isn't their cheaper bed actually limited? And yeah, they have, I mean, Bamboo themselves has quite a few things. So yeah, so if we look here, this is our problem. We're gonna have like a 5 mil plate here, And now this nozzle's never going to touch the bed because of our cross brace, which kind of makes the Hemera not available to us to use.
It's an AC bed also. It looks like heated bed, AC heated bed here.
Is it?
Yeah, it looks like replacing the heated bed.
No beds that I'm
AC
aware
board
of.
for the V2 version, V3 version.
Yeah, the P1P and the P1P or the P1S are limited to 100C, and are known for not being flat. That's one nice thing about the Prusa beds is the way they're tested. They are tested on granite plates. LGX Orbiter is my go-to. Are you thinking the full-size LGX? Or are you talking about the LGX Lite? Have you done much with the LGX Lite? One second. Kicking up. Oh, that was your text. I need it. Duke 8. Don't let him lie to you. This dog is super convincing. He'll act like he's dying and he just knows he's going to get 2 more scoops of food. And he got 2 scoops this morning. He's a big fat fatty. So, meant the light, run them on a couple machines, happy. Yeah. So, we use the LGX full size for everything. And now they've got the Pro or whatever. Granted, we've destroyed the metal gears in the Pros. And the plastic gears in the LGXs are easy to replace. So, I mean, we just keep the plastic ones. So the big thing is, the reason why we can't really go with a Bamboo Labs size bed is we would have to get them manufactured because we can't acquire them any other way. We could kind of go off the Mark 52 bed schematic and make it bigger, but then we still have to fab it. And the problem is that's going to be very expensive to fab out, and it's going to hurt the fact that we are trying to maintain a sub $1,000 printer made in the U.S. as much as possible, and we got to pay U.S. wages and stuff like that. So, like, that's why we're fighting with what's readily available rather than what is what we have to make ourselves. And we really don't like doing too many proprietary parts. Our metal parts are quote unquote proprietary, but if you ask us for the file, you can take that and go to Send Cut Send. You can take that and go to 3D, what is it, 3D Hubs?
Yeah, 3D Hub. Yeah.
Something like that, and you'll be able to make all these parts yourself. Or if you have a little machine, so like if you have something like the milk crate or something like that, you'll be able to make all these parts yourself. We're not hiding that from anybody. We don't want there to be proprietary parts. Which, by the way, if you are making this corner right here, impossible. Unless
laser cut it.
Nope. It's not impossible. You just got to get one of them corner bits. The end mills that are square.
Mm-hmm. You can broach it.
You can broach it, yeah. That's an expensive process. Our electrical engineer, when I was working at with IC3D, the electrical engineer we convinced him that there's a tool for making square holes, and he didn't want to believe us. And we just drilled out a hole and took a Dremel and made squares out of it when he wasn't there, and he's like, "No, what is this tool?" It was in sheet metal.
That triangle bit that spins. I'm gonna say that wrong. Not concentric. Eccentric. How do you say that? Eccentric. It spins eccentric, and then as it rotates, it makes a square hole.
Really? Oh yeah. You sent me that before. That's funky. So let's bring in a LGX. So one thing we wanted to kind of design first here is we want to just kind of plot out what we would do for a extruder mount, right? Because one problem I've had in the past, and where I've screwed up in the past, by the way, this is rotated. There we go. What places I have failed in design in the past is I design the machine and then I design the head, which works about 70% of the time. What happens most of the time, though, like I guess that doesn't make sense. It works like 30% of the time. What happens most of the time, like 70% of the time, is you design the machine, you design the head, and you go, ooh, I want to add this and this and that and that and this. And you're like, oh, either this thing's going to be as tall as a skyscraper, the head itself, or everything's just going to contact itself. And the 300 mil bed you thought you had, now the head's so big that it can't move to the left and right. 50% of the time, it works every time. Yeah. So that's one of the issues I've had in the past, is I need to design the head first, and then so if I need to move something, I can always reference back to this head design and make sure that it's not going to contact anything, and I'm actually going to get, because the biggest problem is you can design a head and then limit the features of the head. Let's try to get as much of this off the front of this as possible. And then you go, oh, well, now I can't put as much cooling on as I want, or I can't put the probe where I need to put the probe and stuff like that. And it's hurt. Like in the beginning of the Daedalus, we sent them out with BL touches way behind the head, and that was a problem because of the offset from the nozzle to the mount to the probe, causing a teeter-tottering action, which threw it off. So our beta testers had to get, Brandon, you had a BL touch on it, right? Off the bat? Or did I already move over to the probe?
The Daedalus had the BL touch.
Yeah. So we had, oh yeah, because I changed it out for you, remember?
Yep.
So.
Still have your tools.
No, you don't. You give them back.
Yeah. Did I give them all
back?
back?
Yeah, I got them back like Murph 2020.
And your stick of deodorant.
And my stick of deodorant. I travel like an engineer.
Yep. Exactly.
All right. So the reason why I go 5 mil is on your non-beta.
How about using the Daedalus head? You
for this?
You touched on that, didn't you? Yeah.
No, so we don't want to use the Daedalus head. We can bring that in. The problem with that is the size. It'll use a full-size LGX is the problem. And you with the full size with the Daedalus head, you cannot use BMG light or a LGX light or a orbiter. You can't because of the front plates. So I can bring it in here.
One of the biggest problems I had with the BL Touch was the
probe crashing.
The probe crashing if it got bent at all.
Yeah.
But sometimes it wouldn't retract.
Yeah. Yeah. I mean,
the failure rate was.
Yeah, I had a high failure rate on them.
Yeah.
So before we sent out the actual printers, we removed the.
We were looking at the Lucid probe.
The Euclid probe.
Right? Euclid probe.
Yeah. Uh-huh.
And then I do like the one that's on the Apollo.
The probe. And it's styled like the Pinta, but it's not the Pinta. But anyways, so yeah, we can't do the Daedalus one, but what we can do is we can kind of keep this as small as possible. This allows us to put the LGX light on here. And what we do is we mount it off this bottom plate. What we do is just make a plate across. But we've been playing a lot with sheet metal, which is what. So we're looking at both the Penda style, but also the Euclid, leaving it up in the air for what people want to use. I want enough space somewhere around this build volume to where we can move off the bed enough that we can do a nozzle touch off. So the beacon probe, it's a really cool probe. The problem is the limitations in boards you can use. So we mostly work in Duet. We're gonna build a printer here with a Duet mini board, but we want to make it to where the back panel for the electronics can be swapped. Like it'll have multiple mounting points. If you want to get this and get it with electronics, we're gonna offer it with the Duet. If you want to get the electronics, you want to go with a Big Tree Tech board, a Manta, an Octopus, or something like that, by all means, you can then do that and go Clipper. I know Duet, I don't know if you can find that file, Brandon, but, or that link I sent you about that.
Yep.
But about duet testing a beacon style probe.
You had to solder onto the board.
You had to solder on the tool board.
board?
Yep.
On the tool board to get it to
for the SPI. Yep.
Yep.
But there is possibility of duet allowing that in the future. So yeah, we're trying to leave this to where whatever your little heart desires, we want you to be able to use that. We want to just give you a robust, quick motion system that doesn't take forever to build and be built with high quality components. That's our goal. If you want to do something crazy, I'll do something crazy. Hey Mitch, how's it going, man? Mitch? Yeah.
The Mitch.
Mitch, did you stream yesterday? I know you were talking about we're going to post the Brandon, can you write down the beacon probe and stuff like that? And what these people have suggested in that sheet.
Stacks that include oversized fixed magnets are not recommended.
What's that?
I just thought that was interesting. I don't think they like big magnets.
No, yeah, that's one of the biggest problems with that. You're talking about the beacon, right?
Mm-hmm.
Yeah, so that's one of the biggest problems with the beacon. Okay.
Oh, didn't Mitch just get
no. Let's go back. Mitch is somehow paying off every giveaway for Voron Zero.
He win another printer.
The first one I believe he won, and then he built it, and it was the coolest thing. He took it to Thanksgiving dinner, I think. Aaron, the clicky is the Euclid probe, and that is something we want to make sure that we have the space on here for it. He's hoping for a third at Earth. So yeah, he made a cool. It was like the green and purple Voron Zero. I think it was a 0.1, and took it to Thanksgiving, then sold it to Cookie Cat, and they had it at their booth at Murph this year. That was sitting next to us, Brandon.
Yep.
And then he won another one. And yeah, and now I'm just curious as to what colors you're going with this time. So let's bring on an orbiter in here as well. Mainly because I want to make sure that we can fit all the mounting up that we possibly can. This is a 1.1, and I don't think, I'm sure people who use orbiters would know better than me, but I don't think the orbiters change their mounting points, have they?
This is what. Oh, I want to know what Mitch is going to do with that rack robotics. The DIY EDM machine.
Did you get one of those?
It looked like he had a box that.
Please.
Kickstarter edition. Power core.
Mitch, did you get an EDM?
That's wild.
So one thing is we need to make sure is that we get we kind of get our filaments lined up here. Because we don't want somebody to be like, hey, I want to go from an orbiter to an LGX or an LGX to an orbiter, and then their nozzle not be in the same spot. It's a magic box, yeah. Put that on the little Voron Zero, man. No, you need to get like a form bot or something. Get something large to put that thing on, and just yeet it. Just do that. So I don't know if you guys saw at Murph, but LDO was showing off a new
EDM. Okay, cool. Sorry.
Backpack EDM. Oh yeah, just sloshing around. I don't know if you guys saw it at Murph. LDO had a new version of the Orbiter 3, that has a hot end built onto it. Kind of looks like a small version of like a Humera or something like that, like just shrunk down. Another thing we should design. Gosh darn it. Let me stop having a stroke here for a second. And I can tell you. Oh, another thing we should design for is the H2, the big tree. I'm gonna post some links in here. If you guys have ideas for extruders, start letting us know. We got a couple of them down. But there's Big Tree Tech makes that extruder, right? Yeah.
Smart Orbiter V3 suffers the Hemera problem.
Smart Orbiter. Yeah. Oh, that's true. But
Oh, I'm not understanding.
The Smart Orbiter V3.
Yep. Yeah. Why?
Because the nozzle doesn't stick that far down from the body of the extruder, okay. So the nozzle might not touch. But the size of it, the H2 has a Revo option, right? I have one of these, and remember, Brandon, it's got the real small motor. But so I don't know if you guys pay attention to any of our designs. The
H2 light's pretty cool.
H2, yeah, just because it looks cool. Anyways, we always put our extruders over our carriages. I really like doing that. That's kind of like always a design goal for us, because then we have our weight pressing down here and not hanging like a diving board off the side. But we could place I don't know if I can get a step file for this. But the BIQU, whatever, H2V2S, we could put sideways. So we have all this space over here with the belts being in the back. We can make the heads wider. And we could hang it off the front if our little hearts desired. That's something that we want to offer people to be able to do that. Right? So, right now, let's stick with where did my chat go? Sorry guys, I lost my chat. There it is. Nope. Nope, that's not it either.
Greg's weight extruder?
Yes. All of the Greg's weight. We're actually just gonna buy all of Lolzbot's old printed ones and just duct tape them down, because they'll be as sturdy as any Greg's weight extruder was on like a Taz 5 or 6. Those things are wobbly as all get out. I am so glad they moved away from those things. But anyways, so one thing is we started working a lot with sheet metal in the last few months. Well, actually, since last year, I've been working heavily with sheet metal. So one idea I have is to not get this made out of milled aluminum. Milled aluminum is a lot more expensive than laser cut plywood is what we're going with, actually. Yeah, we're just going to send it out to Oshcut or Sencut Sen. We're going to get made out of balsa.
I think we have it EDM'd out of Tool Steel.
I mean, we know someone who has an EDM. Mitch, quit your day job. We got a new job for you.
It'll take you hours.
So, but yeah, one reason why I want to have this as far out as possible is because I know some people have been putting probes behind, like with the Voron V2 series of printers. They have that probe right behind. I don't currently like that, but if somebody wanted to do that, we could make this plate interchangeable as much as possible too. So what I'd like to do is sheet metal this. Capture position. I want these holes. So we're going to just start with a basic sheet metal design. I mean, instead of trying to get around all these, I could make them go away. That would work. So now I need them back. Like an idiot. I am very self-deprecating, just be aware. We can get this up to here. Where's my thing at? There it is. Not that far up, you dingus. So if we went up somewhere like there, this is just rough. Now we can go away with this. We don't need these now. 45. But we do need to make sure that we're going back far enough. So let's 40, no, that's 15, 45. We need to make sure we're going back far enough here for our belts, right? So just go 75 is too much, but we're gonna go start with that. We're gonna go over sheet metal, because if we can do this out of sheet metal, do you see any opposition to this, Brandon?
No, it'd probably be ideal on.
Because then we can do a bend up in the back. Let's see if I still have my same. Sheet metal, yep, steel. We'll go steel, don't you think? Oh, no, probably aluminum. Aluminium. Aluminum. So once we get the belts, we can do this flange up. Now we've made this a sheet metal part, we can do all of our sheet metal fun things. So what we're gonna do is gonna bring back our orbiter light, and we're gonna bring back our orbiter light and our LGX. Get rid of these. This body. So what we're gonna want to do is we're gonna want to bring back my body, because I'm gonna do a sketch on the bottom, because I just like to roll that way. Oh, I just can't. All right. Now that I clicked on everything I shouldn't have clicked on, we can do the right thing now. No, I don't want your stupid bolt. No. We just need our placements here. The way we're doing this is we're projecting with the P function. Get rid of this orbiter, because the orbiter's only got 2 mounting points, where this guy has 3. Oh, I just thought of something. What am I doing? I'm not even projecting anymore. There we go. One thing we have to think about is with a LGX and an orbiter, we need to be able to mount our hot ends. Right?
Mm-hmm.
Because they don't bolt directly in. Okay, we got that now. Get that away. Bring back our body. This will give us mounting for these 2 extruders specifically. Whereas these will have to be tapped. These 2 here. And these 2 have to be pass-throughs, because in the LGX, they have nuts in them. I haven't seen the V3 yet. What are you talking about, Brandon?
The print NC.
Oh, yeah, I haven't even paid attention to the print NC in a hot minute.
No, I don't think I've seen it since V1. And it looks a little different.
And one way we're gonna get the rigidity out of the this part is the bends, right? Which right now we mostly do steel on like the Talos to make it very sturdy. We may do steel on this too. It's not going to be super heavy, so I don't think it should matter much. So these will be tapped. Let's just boop. We're gonna go. These are 3 mils. Boop. I should have just done that together, but I didn't, because I'm gonna do this. Not 3.5, 3. So we know what those are for there. So we have those. We want to. Question here is, do we want just a hole here to pass this through? So it'll be like a 4 mil hole, or do we want to cut out around this in case something does change? We probably want to cut out around it. No, you can't. Have to be printed piece somewhere unless you counterbore the hot end hardware into the plate. Yeah, that's what I'm thinking. So another option is to do stacks. Stacks on stacks on stacks. Because if we do stacks, what we can do is we can make another 3 mil plate that is an interface that has no bolts. It has pass-through holes. place it here underneath this. And then what you do is, and that'll be your counter bore for your bolt heads into your hot end. And then you put a plate below that, which is actually the mounting plate that the bolts actually sit on. And then what you can do is if you're changing if you have a hot end that doesn't fit the Mosquito style mounting surface, then you just change out that bottom plate. So that you can do all of your Thetis hot ends. You can do the Mosquito. You can do. We could probably make it to where it works. We'll have to get a thicker plate, but then we can make it work with the Revo Micro. That's what they call that, right? Yeah, the Micro. You can make it work with that. And then what it does, it also gives us a little bit more space going down, because then you have your, what's that? The Pico hot end that was really small.
I think it was teeny. I haven't heard much about that.
No, I have one. I played with it a little bit. But, I mean, hot ends keep getting smaller and smaller, right? So making it to where...
Oh, yeah, Pico hybrid hot end.
Oh, and I mean, people are also using the bamboo hot ends into things.
Yeah, that's
so that
true.
we can make it to where people can just make this plate. And if we make it the right way, if we design it right from the start, people can go to Oshcut or Send and get these made overnight. Yeah, practically free, yeah. But yeah, you can just go have it sent to Send, and if you want to make your own hot end, if you want to do something wild and crazy, you can just get this bottom plate made. That's the idea. Any hubbub about that? Anybody like, you crazy?
Definitely crazy.
You silly boy. So what we will do is, one thing is, there's a 3 mil. Just make another sketch. I'm an idiot. Maybe we should keep a counter. How many times I call myself an idiot? No, stop trying to rename me. I almost did it again. So, no, wait, that is wrong, because that filament is not in the right spot. So let's get rid of this body, because if you look at it, that filament ain't in the same hole. Oh, those don't look like they lined up either. Anyways, let's go off of the LGX light here. You may need to change the... So we're going to want... So this should be 4 mil, right? Yeah, for your thing. What we should probably do is not have the main plate be 4 mil. Have it be wider. I actually have a project in my brain. But it's acrylic. Okay. I've seen people make, I mean, what's their names? What's that printer I took apart, Brandon? You know what that printer was?
No. What were we
the Airwolf.
Airwolf, there you go. Okay.
Yeah. So what is the external diameter of a 3 mil PTFE tube? It's 6 mil, isn't it?
Right.
So let's make this 6 mil. So if somebody wants to get a 3 mil orbiter, which they do have, they have the files for it, they can use it. You see what I'm saying? Oh no. I texted the wrong person about the dog. I bet he ate again.
Is it 4 mil?
What 3? What do you mean?
PTFE
For for a 1.75, yes.
I'm seeing a lot of people selling the 3 mil by 4 OD.
No, you don't want that.
Okay.
No, that's super thin walled. So you're not going to get good, especially in this situation, you're not going to want it. Because the hot ends are built with 6 mil holes. So then you'll get it walk around inside of it. Oh, but Airwolf used plywood to make their hot ends, which is just Okay. And then if you want a new hot end, they go, actually, we won't sell you a hot end. Why didn't you cut, you stupid hoe? We won't sell you a hot end. You have to buy the whole motion system, and that's $1,000 to get a replacement hot end. Tell me how silly that is. Which I need to get back on that thing. Okay, let's figure out what the spacing's all weird about. Yeah, it's not right. So let's move this. Oh, what did I just do? Move. I'll have to create fix that. Go away, sketch. I don't like you. Let me pick something that is relatively decent. There it is. What's the bottom of this thing? Let's go off of. Give me like a full circle here. Jiminy Christmas. It's got this screw thingy. Okay, in this design, this screw thingy is not centered. All right, we'll have to dig into that before we move things, because that's goofy. No, Airwolves are not cheap. I'll happily send you pictures of the shattered hot end that just snapped right off. And it was a school, and they reached out to Airwolf, and they're like, hey, we have an Airwolf, and the hot end's broken. And they're like, oh, sweet. It's $1,000. And it is such a bad design. It is terrible. It looks like these holes didn't get placed. Okay, they did. Okay. So let's place this all down correctly so we can kind of work from here on what we're doing. Let's go off of this. Place that on this hole. Okay. So even if we did this out of steel, we will meet the minimum thread requirement for M3 bolts with 3 mil plate. So like the standard for the amount of threads you need to get the proper torque on the bolt. Am I saying that right, Brandon? To actually get the hold down that the specification is set for the bolt, you need 4 threads. And an M3 is 0.5 pitch. So we'll get actually 6 threads in an M3 plate. So we're meeting that minimum spec. We're actually exceeding it. So we do that. And then these are bolt holes for the LGX, which, I mean, the LGX just looks cleaner. I don't know. Is that just me? Granted, it is made out of the. Are you gonna move? No. Apparently, you're not gonna move. Wrong thing. There we go. So we're just gonna put some things here real quick, so that if I design this bottom plate, 3.2, we like to give it about 7 mil of space. We're just going to put these references here while I design this. They're 3 mil tall. So that I don't interact with that, right? See what I'm saying? Design a V0.2. Oh, nice. Don't they have? Oh, the V0.2 is different, though. I don't know. I only have a V01. V0.1. There we go. And that is not finished. Yeah. So I'm gonna pull in that how you spell mount. So we're gonna pull in our Revo rigid mount Revo heatsink to do our first plate here. Only because it's got the same mount up as a mosquito. So that'll tackle 2 of them right off the bat. Why is that? Why are you the way that you are? You're just like your father. I didn't even need to do that. I'm an idiot. So we're gonna add 6 mil to this in plates. What? Did you see that happen, Brandon?
No, what happened?
It moved, and it was like, yeah, we're good. And then I was like, all right. And it's like, yeet.
The old reverse odd in.
Yeah. So, this cold sign, then we're going to move it down 6 mil, because that's what it's going to be. 6. So we'll have 2 additional plates here. So, Manic, what are you working on now? What any fun things you can talk about for your videos? How are we going to mount to this is the question. You know what I'm saying? They're going to have to be, you're going to have to be far enough out to be away from your hot end, but also close enough. Finish a video about a display designing the part for a client. How to charge for that? Oh, that's the fun stuff. Figuring out how to charge. So we're not going to be able to line them up perfectly beside each other. We're going to need to I think one thing that'd be cool for because I know Joel has been doing doing a bunch of print farm stuff. So what would be cool is for him to make a video on how to, why did I do that? On how he does his pricing for print farm work. I know he was selling things a lot cheaper than a lot of other people though. So not the most fun video, but it isn't. Yeah, absolutely. There's a lot of things that don't get discussed in this community that really should. It's like people don't want to talk about the hard things though because they're not fun. Let's make sure that this will got the space here. So the problem with it being this close is if we put so we like to have a 7mm space around a socket head bolt. If you're putting on a standard fan shroud from E3D, it shouldn't, because it's not sticking down that far. It shouldn't. We should be fine. But we have more space. So let's go 35. Let's see if we can get a 35 in here. Spacing. It's a little bit further than I'd like it to be. But it's far enough away from the actual heatsink to where even there's that hot end that starts with a T. It's like a mix between a mosquito-esque and a volcano. It's a crazy thing. About his billing and reference to the video. It was more complex. So if we do, these will be tapped. 3. Just go 3 for now. We can always size up or size down depending on the plate we're working with. That was very nice, Brandon.
Thank you.
So these 2 bolts, you think 2 bolts will be enough, Brandon?
For the
hot end itself mount. Granted, the hot end is mounted with 2 bolts anyways.
Yeah. Yeah, it should be enough, right?
Yeah, the only problem is I would put 4, but then it lands on the mounts for the orbiter, which may be adjusting here shortly. So the normal bolts that come with the orbiter, we're gonna have to. Okay, man. Pooch is super good resource for that too. Yeah. I've seen a lot. He's been posting a lot of like shorts and stuff lately, which is cool. So
instead of jeans.
No, yeah, he doesn't like jeans.
The pants.
He is in California.
Yeah.
So let's go with a 15 by. Now it's gonna have to be probably 45. Let's do 45 for now. Oh yeah, it's not centered. Duh. What are we looking at here? 43. Let's just go. We ain't gonna go wild with a stupid number here. All right. What I could do is add a 3rd bolt hole right here. But that might be a pain in the butt to get to. You know what I mean?
I think 2 would be acceptable. Maybe if you could locate it in some sense, but...
Who to what?
You could locate it in some sense.
Yeah. Location might be the only problem we run into here. So let's do this. We'll bring up this guy. And mosquitoes are mounted with M2.5 because they're stupid. Because who has an? I got one of the first mosquitoes, and the first thing I got at home, I was super excited to use it, and then realized I had no way to mount it.
Yeah. And then they have don't they have a 0.9 millimeter Allen wrench?
Yeah.
That's to be used on it.
Well, if you want to take the whole thing apart.
Mm-hmm.
So let's look at what the head size. So the head size on an M2.5 is 2.5 mil tall with a 2 mil drive and 4.5 diameter. So now we can take this cold side away. What we're gonna want is there. We're gonna want this to be 4.5 diameter. So we're gonna want this to be 5. And this to be 5. So the heads can sit in there snugly. And then this will be our top plate. So let's take away this plate here. Bodies. Take this plate away. We'll extrude. These ones don't need to be here. Shoot. Let's just do it this way. Nope, that didn't do that. Gotta go back. Undo. Like most of my life decisions. Let's do it this way so that we keep our same sheet metal rules. We're going to go on side 2. Yeah. So then we can come in here and that one's made. Then we can come back, bring back our sketch here. And we're going to do it again. But this time we're going to keep this. What am I thinking here? Yeah, we're going to keep those. Yeah, I'm doing it right. I know what I'm doing. So you'd have sandwiching plates like this. Now let's get rid of the sketch. Let's move this plate and this plate down 3 mil. We'll bring this plate back in. What did I do there? Too far down. Blah, 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 blah. Whatever. Okay, let's move these plates up. Because apparently I moved them too far. Let's see. I'd like to know how far I'm off. I'm here. Off I am here. Ignore my stroke. All right, I was off a mil. All right. So you'd have a stack. We're going to clean it up, of course. But these ones we would make smaller. So that, like this main one, because you're not going to want to change out this top plate that often, you're going to want to leave this because it's going to have the belts mounted to it. So you don't want to have to remove this and rerun your belt, because if anybody's run a Core XY belt system, they know it sucks. So we want to leave this on as much as possible, which is why we're leaving the hole here larger, and we'll make the hole. So if you say you want to go, hey, I'm using a 0.5 or 0.5, not a filament, 0.75 millimeter filament, we would have these step down to 4 mil, so that your Bowden tube is retained. But if you want to go to a 6, all you have to do is change out these plates, mount up your hot end, and you're good to go. So what we could do is back to the sketch. 4. Back. I already did that one. Okay. What did I not do? This one. Not that one. All right. Now, these should be good. They're not down to 0.4s or 4 mil. So then what you do is this middle plate, this bottom plate, this middle plate isn't bolted directly. It's going to be sandwiched with this here and this here. Thought I got rid of these. So this here and this here would is just pass through. The bolt heads would go here and here for your hot ends mount, and then on this one the bolt would go. Gosh darn it! The bolt would go through here and here, and bolt into this top right here. I'm an idiot. I deleted the wrong holes. Disregard my stupidity. These are the holes we're going to delete, because these are for the orbiter. So we'll clean that up. This is going to make it to where it's going to be the easiest to mount your hot ends. And then this bottom plate and middle plate are the only things you're going to have to do a crazy, weird hot end, whatever you want to do. These are moot points because... Oh. Did I? This is part of what? What is this part of? Oh. Because they were just references. We don't need them now. Just come down here to the extrude. What are you doing? Why are you running? Okay. That's the wrong extrude. That one. Delete. Delete. Oh, there we go. All right. So now the next thing we need to figure out is the belt comes in between these 2 points here. So we need to bring in an idler.
How long are you streaming for?
Not sure. What's up?
Just curious.
Oh, probably.
At a time.
No, I did not set the time. Probably 2 hours. We're already an hour and a half in. So we're going to bring in a Gates idler because that's what we use. Oh my goodness. Sorry for the loud things. I just need to delete. Just exit out of that so it stops making noise. Place yourself. We're just gonna copy this one over. Let's see what our spacing is here. So that's where our belt's gonna come out. Granted, they're not gonna be level like this. They're not contacting. They're gonna be stacked differently, kind of like the way this is, right? But we look at the system here. Say this belt goes back to this motor, right? This belt to this motor, then up to these idler stacks, over to the back of this idler stack, then up and hits this idler and comes to the head. And then this one is the opposite. This one goes back to this stepper motor and comes up around, hits this idler and comes to the head on either side, right? So I'm just using this. Don't think I'm being crazy and just gonna melt idlers together. What we're gonna do is we're gonna move these up. No, not to the side. Just want those high enough to know that where my line is. This. I guess I didn't even have to do that. Let's move that back down. What we're gonna do is we're gonna, yes, capture position. We're gonna do some funky stuff here to find this location. We're gonna go like that. We're gonna go like that. That's gonna give us what's this distance here? Stop doing that to me, you butthole. Sometimes fusion, you know. Tie that one down. Now we can go across, and we can see that this is where this needs to be. Or to make this easier, we're just going to cut straight down. No. Like I said, this is going to be kind of the down and dirty design right now. What'd you do? Why you do me like this, Fusion? And it's fine that way. Okay. Okay, so now if we're going to do a bend, we need a flange. It's going to let me do a flange here. Why, let me do this. Oh. It's probably mad at me for deleting that. Of course, Fusion's going to be like this. Oh, because now it's saying that it's not a stupid. All right, we'll turn this into a sheet metal part again. There we go. 3 mil. No. What? Okay. I'm going to change our rule here. Sheet metal rules, aluminum. Oh, I'm going to have to change that. Really? It's not going to let me change mine. What? Sorry, guys. Boop. White. 3. There we go. Not sure why I kept moving there. This design. Oh, Oh, it'll let me change it here. No. Oh, I just changed it. Here, let's do this. Nope, not save it. That's a bad idea. Just gonna have to revert a little bit here. Because something went wrong, and I didn't catch it when it happened. Oh, that's right. What does this show up as? What does this show up as? All right. We should be able to... Let's leave those references there for right now. Let's see if it'll let me do a flange. It'll let me do a flange. All right. Annoying piece of crap. Let's do this again. Redundancy is always fun. Copy this over. Boop. 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 Oh, by the way, if you guys don't know who Brandon is, you should. He helps out me. Helps me out a lot. There we go. He's the one who you see at our booths at events.
I'm just here for good looks.
That's true too. A lot of people for some reason go to him thinking it's me, except for that's like a major insult to him. But yeah, he's been when did we meet, Brandon? 19?
Yeah, Murph 2019.
Brandon started out as a customer.
I paid my way in.
Yeah, he paid his way into friendship. Really what happened was they walked up to me first. They went and him and his wife went and talked to my girlfriend.
The cool. Sorry, yeah.
The cool one, yeah. And then I don't remember what I was doing. I was, doing my normal walk around the event and not being at my booth type of thing that I do at all of the events. And then they ran into me when I was drinking.
Yeah, we got some ciders.
No, was it ciders or ginger beer?
Ginger beer. I think it was ginger beer. Yeah, I think you're right.
Pretty sure it was gingy. And what is going on here? It's not letting me flange it now. That's so weird. See what I'm saying, Brand?
Mm-hmm. I'm not super versed in the flanging. The flanges.
The phalanges?
Is it because the drawing's not there anymore? Or because you went past the drawing since you did the push pull?
Are you more of a metatarsals kind of guy?
Mm-hmm.
Instead of the phalanges? Sorry.
Did you see that Hank Green? Sorry, side tangent. Did you see that Hank Green TikTok? Where he's talking about busting every bone in your body. He's like, well, there's a lot of small bones in your hands.
There's a lot of them.
It'll take a while.
Yeah. What is going on here? I'm wondering if my current rules are funky. There we go. I wonder if it was just trying to say, no, you couldn't bend. Nope. It's still being a motherless hoe. Why you do me like this? All right. Want to see something cool? We're just going to go like that. And we're just going to act like this part doesn't exist. And I don't know what... Oh, it's saying it's still 5 now. Okay. Okay. Whatever, bud.
Sure there, bud.
You're just a silly goose there, bud. All right. Look at this. Ta-da!
Professional.
Professional. We're just gonna act like it never happened. Nobody saw that, right?
Has not been seen.
Make sure everything's lined up. All properly like. Boom shakalaka. All right. Oh, that stuff's not lined up. This all should be like 1 mil too thick now, or too high. That's what. So much is making sense now. Because I moved that down 6 mil, and then it wasn't lining up. Now it all makes sense. And I should have caught it earlier, but I'm a dinkus.
Amateur.
No one saw that part end up. Yeah, like I said, this is a very dirty, down and dirty
VHB and zip ties
design. The one thing I have to worry about here is, yeah, we should be good. Because we look here, both of these idlers are above this bar. Right? And that's what we absolutely need. We need to make sure that this bend ends below this this plane. But how high above this plane do we need to go? I think it was like 20, 75. So let's go 25. So we have space above the belt. And I need to modify this. Come on. Rotate the right way. You dumb, stupid, dumb. Okay. It looks like 6 is the plane. Yep. So then we go another, so 25, yeah. So then we can just bend this plate. So this plate stays standard. And we can have a clasp on the back to where it holds the belts in place. Zip ties. Yep, that's how we do it. But yeah, so then we'll make 2 slits here so that the belts can come in. And then what this will allow us to do is this will give us a lot of space around. So if you look at just your come on. This is what I'm looking for. If we look at this, we have a lot of space around it for fans. We'll have space in front of it for fans. And also below if you need it. I don't like the fact that this is so wide, but for the mounting, I think it's gotta be. To give us the most accurate. What are you doing here, Hole? Go home.
Go home.
So, yeah, we'll be able to put fans around. The big thing is spacing, right? So,
did you say that's the max height you can go with that bend?
No, I can go much.
That bend.
No, we can go much higher.
Just how tall is the tool board?
Here's the problem with the tool board. Here's the problem with the duet tool board. Let's go with that. Let me pull up the file real quick. Then Talos. What time is it? How much time have we on here?
Hour and a half.
Okay, I want to spend the last 15 minutes breaking down a Talos component. So just make sure that I don't overrun here. Tool heads. Okay, where you at? Where you at? Where you be? I know you're in here somewhere over the rainbow. Okay. I know you're in here. Where are you at? You stupid, stupid, stupid. Sorry. So the tool board is large. That's the biggest problem. Is how big the tool boards are. Has anybody here worked with the can? Oh, Amanda, you recently did a can on your 2.4, right? Because then, I mean, those tool boards would be a lot easier to work into a design like this. Yeah, the Big Tree Tech one. Because, yeah, so bring this in. This is the biggest problem here with these ones. Just look how chonky it is. And Duet says they know that this is a problem. But it's wider than the carriage set is. See what I'm saying, Brandon?
Yeah, it's bigger than I remember. For some reason, I was thinking it was only like 30 mil.
No, she's big. She's chunky. But yeah.
That thing's huge.
Yeah, it's stupid. It's real dumb. And they have all of the wires coming off the sides, which is just...
Yeah.
It has it coming off all the sides. And don't get me wrong, like you said, there's some of their stuff, it seems like there's not thought behind it. But it actually, I think it had too much thought behind it. I think that's what the tool board's problem is. Because if you look, this is a bolt hole pattern. That's a strange bolt hole pattern. What's that for? That's to mount on the side of a Chimera. Well, what if you don't want to use a Chimera? Well, why? Like, the problem is why wouldn't you want to use a Chimera? The whole thing was this was designed specifically for the tool changer.
Oh, is that designed for the old Chimera too?
They have an old one. This is the newer one with the smaller. So if you look at the
fit on the XS or whatever.
Yeah, to fit on the XS rather than the standard Chimera. But if you look like this, I believe it should be this way. So this is your top power can, and then this is your hot end stuff with let's see, your fan stuff like that. So it goes back around. Yeah, so this is your hot end stuff. So it goes up towards the fan, right? So your heater will go straight down to your Chimera and all that other stuff, and your fans and your in-stop stuff like that. And then back here is your stepper motor to go straight up into your stepper motor. Like, so there was a lot of thought put into it, and it was intended for a specific purpose. But tool changer's dead. Like, that's the problem, is that it was just too much and like it was too keyholed for the situation at hand.
Do you want to show off the Talos some?
Yeah. So, well, let's wrap this one up. Yeah. Okay. So, this is the start, right? What we'll do is we'll do belt pathing next time. We'll with all of our idlers, we'll do belt pathing, and then we need to start working on Z at some point here pretty quick, so that we can kind of figure all that out. This shouldn't be too crazy of a setup. Ooh, one thing I just thought of though, Brandon. If you have a, what am I looking at here? We put an orbiter on here. Will it contact those carriage? We may have to space the orbiter up because the holes for the carriage, you can see them hit highlighted there. They'll contact.
Yeah. Okay.
The LGX could get away with it with 3 bolts, but we'll probably have to space them up, which is not that big of a deal. Anyways, so what we've done here is we kind of got our tool head set up. This is ugly. This is not what it's going to look like. If you guys have suggestions, of course, we're going to clean it up, make it look a little better, but we want to make it to where it's modular, right? You do have a little bit more space on the back here. Let's make sure the orbiter will fit if we space it up. So that we can make sure that everybody's going to be able to use the hot end they want. All right. Yeah, if you guys have any suggestions, we're going to probably put out the sheet for people to put in their ideas and stuff like that. Make sure you put your name next to it so that we know who put it, so we can give you credit on it. But yeah, so I noticed the hole for the center right here disappeared too. That thing did a lot of weird things. All right, so we are going to end this part, and we're going to look at, let this save. If anybody wants this file as we work through this, I'll happily share it with you guys. So I was thinking for the Talos, we can either do the full assembly like look around, or we can do Z or X and U. Anybody have any suggestions on what they would like to see? The Z motion system, the XU motion, or the just a generalized. Curious to see everything. Full assembly, please. All right. So which one? We've got. This is 1200. Not this crossbar. This one's not as cleaned up as the first one is. Let me delete the other things so we don't have. There's a lot of components in these big boys. All right. So that's the ugly 1200 one. We'll open up 3 things here. All right. There's 600. This is what everybody's been seeing pictures of. And then the side by side should be opening up here as well. So if you want to see the size comparisons, like this is the one that we've been showing pictures off of this whole time. It gets much larger.
Okay. You don't have a Daedalus model to throw against it, do you?
Nah, that's just wrong to do, Brandon.
Open the inside of it.
It should fit on the bed of the 600, the whole printer. Mm-hmm. Okay, so 600. Get it from the front. The Z. So one thing I'm sure a lot of people have seen this. That, hey, this looks a lot similar to things on the market, mainly like a Mod-X. I've talked to a lot of people who have used Mod-X's, and a lot of them despised the assembly part and just how much extra fluff of metal parts are on everything. That's why we were able to get this thing moving so quickly. There's going to be covers on all of this, of course, but right now, and of course our Chimera model is a dookie looking. It's not pretty. So our X head, our U head, so we got a main sheet metal part here. It's bent up. This is all steel sheet metal. So it's going to be very rigid. So we'll have these 2 motors will be fed directly from the main board, the X and U. We'll have a cable chain coming up. It mounts here. This is moved quite a ways back than what it would normally be moved back. You'll have those come up, and they'll plug directly into these motors. For the tool boards, which these are the tool boards that we were looking at on the smaller printer, you'll have 1 CAN wire come up, plug in here, power wire come up, plug in here, and then it splits it out into 4 individuals. So you could do more. Granted, we're only going to be using 2. You have your 2 cable chains that'll come out. The cable chains aren't on this model only because when you're doing rendering, the cable chains are really hard to move around and whatnot because they don't move. Actually, they're kind of like set in space from IGUS. So, but if you look, the whole Z motion system, this is a whole subcomponent. This whole crossbar is a whole subcomponent. So, and then the whole bed system is a whole subcomponent with 40/40 extrusion going across, whereas like Mod-X is using 20/40 to go across, and it's just not enough. Another thing Mod-X did was they're using a 40/40 pattern, whereas we're using a 20/20 pattern. Yes, Mod-X, it's a Mod-X FU. The Daedalus was an FU to some other printer brand. The Apollo was an FU to another printer brand. Let's be honest, the reason why I started Project Red was because I was just tired of the crap that was being made. So One problem with the Monixes is they use one bolt into the end of each extrusion because it's a 40/40 pattern. So it uses like I believe it's an M8. Whereas we're going to be using we're using a 20/20 profile, but in 40/40 mil. So we're going to have 4 20 mil M5. It's a solid reason to do it. Yes, it is. We're going to have 4 20 mil M5 bolts. So our clamping force is going to be much higher than that, like a single M8. It's also going to index it so it's not going to spin or anything. Everything's going to be a little bit more strongly put together. Let's put it that way. So one thing that's the way we're doing our Y is NEMA 23s. Your motor goes to the bottom, and if you've messed with a NEMA 23 in the past, the motor itself is not tapped. There's no threads on the motor. So it's a pass through, and then this top plate, it doesn't show it on here, but we had the top plates made with a nut that's like welded on to this top plate. So it's very strong, and it's going to sandwich together, and it'll be able to slide 10 mil. You'll have 10 mil take up in the belt. The belt then goes past, we'll see here, and hits this clip here. And goes, and the bolt goes through. There's a plate on the back that squishes the belt so it can't come out. And that's how we're mounting our belt. Some people have seen the enclosure model. If you do choose an enclosure, the back 2 panels are on hinges and they fold down so you can work across and lubricate your rail across the back and everything without having to worry about it. One thing Modix does is they sell it with linear rods for Z, and they want you to pay like $900 to get linear rails. Ours comes standard with linear rails. They're MGN 15s. On Z and Y are MGN 15s, and X and U are on MGN 12s with the H carriage. The big thing is even if you don't get the enclosure, this bottom panel with our logo will be there. This right now we're kind of deciding on one of two things: either having it just painted with another color material on the back, or light up red. I like the idea of having an LED panel down there and lit up red. And of course, in my head, I'm like, oh, it could be a status indicator, but you don't really want that. It'll be on the display. It will have a display over here. The big thing the reason why we're coming out with really 3 sizes is because, let me see if my simulation stayed. No, my animation stayed. Did it? So it's an ugly animation. All right, let's bring this down. But if you see here, each end of your Z motion will come assembled. I don't know where that one is. That one just yeeted itself off. But there's another extrusion right there. Anyways, these will all come pre-assembled. You'll have to put on these 2 other like isolated ones, but these just slide down. So what you would do is you get these front plates with your Y motion all built and your X and U completely built. There'll be cable chains on this, and there'll be cable chains on this back portion. All you do is bolt this down. Really what you do is you stand it up. Let's play through it real quick. So it's in reverse. Sorry, guys. So yeah, you'll stand these 2 parts up. You'll slide in your sides. You'll put on first you'll want to put on your bed. So it just drops down on your Z components. Oops, wrong thing. And bolts directly on top of your Z components. And then once that's done, you just drop on your X and U and bolt it. You'll then have to tension your X and U motors. But other than that, everything else should be golden. You'll have to bolt on these bottom belt clips, so this belt will be tensioned from us. So you'll be ready to go. Casters come on the machine. Enclosure is going to be an option. And IDEX from the fact, like right off the bat, you're getting IDEX. It's going to be a little bit bigger than a standard like ModX or a Make It printer. Only because we want the head to be able to go completely off the edge of the bed. And we've got a lot of extra space that the heads can run over here. Mainly because we want people to be able to use a touch probe system. Kind of like a clicky probe. Sorry, there's a motorcycle outside. A clicky probe style machine, but a higher end probe. And we're going to have a camera, an offset camera here. We've been testing. So that you'll be able to run it'll be a script that you run your nozzle, and you'll be able to adjust your offsets from nozzle to nozzle. And then we also want to have a nozzle touch-off probe on this end, so that you can probe your whole bed, and then you go and touch off each nozzle, and you know exactly what offsets you're set at. Just trying to make it because this is going to be a very large bed. So we want to make it as user-friendly as possible to get a very good first layer. So, but yeah, then, so there's this one. Let me, front, but it says back. Oh, second. Nope. I have something else to show you guys. So we've got the enclosure version. So the whole lid lifts up. These will be polycarbonate windows, 2 on the top, 1 long one across here, 2 on the front door, and 1 on each side. The next thing we have to do for the enclosures, once we get it on, extruder options. Right now we're doing the Hemera with the high flow Revos right now, but extruder options are going to be kind of open because yes, we're going to start with that, but the Mosquito Magnums, the Mosquito Magnum Pluses would work really well on here with an LGX. Really, they would work really well on here with a. So one goal I have of this is I want to be able to bolt on a QR extruder from Bondtech with an LGX, or sorry, a QR 3mm on to it with a Mosquito 3mm, because I have a lot of 3mm material that I could just push out. So that you'll be able to, the goal will be to make plates that you just bolt those on with and be able to utilize everything. You may lose a little bit of Z, but right now we've already got it built in with 650 in the Z and not 600. But like I said, these these 2 panels here will actually fold down. And so that you can access your linear rail to lubricate it. Tension this motor if needed, and tension that motor if needed. So we're trying to think of everything. One thing we do want to do is cut out a section of the bottom of the back, and add in for the ability. We want to have the cutouts for when we release them, but a chamber heater. 4028 part cooling fan. What is that? What are you talking about? That is.
Oh, is that like the CPU?
Oh, you're the server fans. Yeah, those things are chunk. So, are you thinking about going like laminar flow style? Oops, one second. Let's go to XY assembly. Are you thinking laminar flow across the area, or are you thinking like just on this thing? You could definitely fit one back here. But right now we were looking at the 5015s to start, and they snug up on here. We'll add a bolt hole pattern on the back for the 5015s. Haven't used the 4028s, but I know not for printing. I've been around those jet engines when I was around servers, and they spicy loud, spicy to the ear. So, but yeah, I know we're at the 2 hour mark. If there's anything specific, let us know, and we can probably dive deeper into each thing on the next stream. Part cooling, they work well. I haven't looked at the Eva in a while. I just typed it in so I can look at it. So yeah, we'll look at that and see what. Because right now there's a lot of that stuff that's done right now. The system, the where this is right now is planning jigs out for everything for quick assembling. So the idea would every one of these units would be assembled in house, then disassembled, put on a pallet, and shipped out. Yes, this will be a palletized machine, mainly because, but it's going to be a small pallet. It'll be flat packed. We right now we're speculating it being no more than an hour of build time, because if you look at the bottom caster mounts, we're going to have plates in the bottom that this just slides down, rests against this, and all you have to do is put plates on the out, like jig plates on the outside to make sure that it's all sitting square, and then bolt it all down. So assembly should be very quick for this machine. And then everything will be wired in subsections. Then you just mount up your electronics box and plug into the quick disconnects on the outside of the electronics box, and you're ready to go. Yeah. And if you guys want something specifically tore down, because like we have our subsections that we can tear down. I'm a big fan of my Z motion. By the way, this is steel. So yes, this is only 3 mil thick, but it's very rigid material. So quick disconnects, yes. Yeah, we use we've now recently switched over to the Molex Nano Fits. They're capable of 6 amps of power each. So any communications going over that, and then for our power, all of our power quick disconnects are going to be, except for right here, these are screw terminals, but the rest of them are all Anderson power pole connectors, which are capable of 30 amps apiece. The bed itself is AC, so you are going to need a 15 amp breaker per bed. So, which is kind of sucky. You okay there, Brandon?
Yeah, no.
No, it's a lot of sounds going on over there.
But yeah, drinking water.
I got you. Well, guys, we're gonna call it for tonight. We'll be back on this. I know someone suggested Saturday morning streams. We'll try to get some of those scheduled, and then we'll continue to do these. The only reason why we are not doing, we were gonna dig into the X and U and like have it in hand in person, but my personal shop that I'm doing all this in, it was 99 degrees here today, and our AC's like, nope. So it was like 85 in there, and I'm fluffy, and I started to melt. So I was like, I'm going to my office, which helped a little bit. So, but yeah, thanks guys for joining. Really appreciate it. We'll be back. I'll try to do something Saturday, but we're going to try to make this a standard thing every couple days. We're going to have a stream doing the design work. I want to have working whatever we call this. Start thinking of names. If you have names, I will give you credit like no other on a name. If you guys can think of a name for that new printer. Names are hard. So, but yeah, let us know if you have any specific questions. You guys want to look at something specific or suggestions for what you would like to see in that new printer. Just let us know. And we're going to be sharing the design files, and we're going to be sharing the goals list as we progress here, so everybody kind of knows what we're working towards. So fun to watch someone else yell at. Yeah, that's what most of Fusion is yelling at it. It's a hate relationship. But yeah, all right guys, thanks for coming. We'll see you on the next one. Have a good one.